the article 91, which is related to heat transfer analysis in MATLAB steady state transient solutions. Basically, in this study, I have just represent the heat transfer model in MATLAB to focus on the one-dimensional heat conduction equation. With the steady state analysis involves the solving of one-dimensional, two-dimensional, transient heat conduction, and explicit finite difference scheme implemented in this article. So we have just implemented that article based on the time-dependent heat equations, which allow the simulation of temperature variation over the time, the behavior of different thermal conditions under the different materials, demonstrating the influence of materials properties basically. So the thing is that I have just written its abstract with the keywords of and introduction. In the introduction, I have also added like how steady state transfer of temperature distribution within the material over constant and over different time basically, how we can discretize and solve the heat conduction equations efficiently with the basically in terms of we called it the principles of heat transfer equations according to the foundation for more complex multi-dimensional or coupled heat transfer problems. So this is the equations which is heat conduction equations. Basically, this is a figure diagram which provide us how temperature dependent with the heat based on the different materials. So I have written the objectives according to the complex heat transfer problems with more multi-dimensional and coupled thermal systems. This is a problem statement I have written. Mathematical approach. These are the governing equations for used heat conduction in one-dimensional solid rod, and like I have just added T representing here temperature, then alpha representing here thermal diffusivity, then thermal conductivity, density, Cp is the heat capacity, then spatial coordinate and T is the time, and then steady state heat conduction equations are added here. In terms of I have just more explained and expanded the spatial discretization with the steady state discretized equations, and these are the heat transfer equations with the finite difference method according to different methodology of the 2D plate heat transfer. See, then external heat transfer analysis. So these are the different equations used in one-dimensional, two-dimensional, and two-dimensional heat transfer equations based on different materials. In the MATLAB simulation, we have just focused over the MATLAB script, how we can develop the script over 2D equations, over 1D, and over 3D surfaces plots with the animation. This is the steady state temperature distribution output results of MATLAB. Transient temperature distribution. This is the transient temperature distribution at for the 10 second of time in three-dimensional. Steady state temperature distribution. Okay, this is basically transient heat transfer crank Nicholson scheme. Yes, this is the transient temperature distribution for 2D plate over time, like we just called it 0.25 second. Yes, basically I have just added the complete heat transfer analysis based on the different 2D, 1D, 3D dimensional of temperature distribution over the time in terms of we called it in different materials. So these are the outcomes and discussions, like how what methodology we have used. Basically we have used the uh, uh, Courant Frederick Fredericks and Levy methods condition, basically, which basically use the different uh, material, like different equations, its methodology, and then I have just implemented the Crank-Nicholson method. We have basically used two different methods to uh, get the output results for the thermal conductivity of the heat transfer methodology of different materials based on 1D, 2D, 3D surfaces in MATLAB simulation. Okay, I have written these are the future works and the advancements and the references. Let me show you the MATLAB equations, like the MATLAB models. These are the MATLAB models I have just generated. Let me just open it. So basically, yes, heat transferring in 2D plate. Basically we need to these are the MATLAB code. Let me just run the heat transfer 2D plate. Yes, these are the transient temperature with the different time scales of and the steady state temperature. And this is basically heat transfer with 2D and 3D plates with the animation, like how the heat transfer moves in different temperature, steady state temperature distribution, and the transient temperature distribution according to different time scale. Temperature versus position. See, these are the animation of temperature versus position according to different time scale. This is a 2D transient heat conduction. See how heat changes according to different time scale. All the code is written in different files. You can run the files and you will get the output results accordingly. Okay, thank you.